Hello, this is lesson 63, which would have been delivered on Thursday, the 19th of March. I'm going to carry on. If you remember, the last time I did one of these class lessons, I decomposed this here, this fraction here, into its partial fractions. Came up with b is 2 and a is minus 1. So that's in the Panopto for lesson 62. But yeah, assuming you can do that. And then I finished by saying, so now if you want the integral of this fraction, it's the integral of the first one with a minus 1 plus the integral of the second one where b is minus 2. Okay, so you can pause that and have a little look at it if you want, but I'll carry on now. Yeah, and I've also said it's integral of 1 over x dx is ln x. What leads on from that is the integral of 1 over x plus a constant dx is ln of x plus the constant. Okay, so back to our integral here. It's the integral of minus 1 over x plus 2 plus dx, plus 2 times the integral of 1 over x plus 3 dx. So what I've done there, that one's there for dx. I've separated this into two integrals. There's an integral, and this is this 2, it can be in there or out there, and I've put it out there. That's dx. So you can treat this a bit like a bracket. Okay, so this is minus ln x plus 2, and that is the minus there. Think of it coming out there, so it's minus ln x plus 2 from that one there. And then this one is going to be plus 2 ln x plus 3 there. Plus 2 ln x plus 3. And you put a constant, I'm going to put ln c. Because when we combine all this together, this is ln x plus 3 squared divided by x plus 2, and then this c goes in there. So I'll explain where these come from. That one's a minus, so it's in the denominator. There's a 2 there, so it goes up there to make a power, and it's a plus, so it's plus, that's the x plus 3 squared, and a ln c combines in there that way. Or if it wasn't there, you can just put plus c at the end, but that's a bit more mathematically what we do. Right, next one. Find the integral of 2x plus 1 over x minus 1, 3x plus 3. So we've got to start with the partial fractions. So we say 2x plus 1 over x minus 1, 3x plus 1. It's going to be a over x, b over x minus 1, c over 3x plus 1. And then we multiply both sides by, and it's x minus 1, 3x plus 1. So that's our next step. So this side, the denominator cancels. This side, for the one with the term with the a in, it's just the x that cancels, because we divide x here and multiply x here, so they cancel, and we're left with those bits there. So likewise with the b, the x minus 1 cancels here. So we've got this one and this one. So it's plus b, x, 3x plus 1. And the next one is c, so the 3x plus 1 cancels here. And it's x minus 1. That's a minus there. So we start with x is 1. And the reason we're doing that is because then all the terms with an x minus 1, and there's 2 of them, will become 0. We're just left with a term with b on the right-hand side and a number on the left-hand side. So we'll be able to work out what b is. So 2 times 1 plus 1, a times nothing, plus b times 1. And then 3 times 1 plus 1, which is this here, is 4. And then this is c times nothing. So therefore, b, that goes and that goes because of those zeros. Left-hand side is 3, right-hand side is 4b. So b is 3 divided by 4. The next one, x is minus 1/3, which is a bit fiddly, but we can do it. So we put minus 1/3 in here. All the ones with 3x plus 1 now are going to cancel. So we're going to be left with a number on the left-hand side and this one on the right-hand side, because this hasn't got the 3x plus 1. Okay, and then we'll be able to work out what c is. So 2 times minus 1/3 plus 1. So it's a, and that's times nothing. And then this is b times nothing. And c times minus 1/3 times minus 1/3 minus 1. So minus 2/3 plus 1, got 1/3 there. That goes, that goes. This is c times minus 1/3 times, now minus 1/3 minus 1 is minus 4/3, because a whole one is 3/3. Okay, the two minuses make a plus, so they cancel out. And I'm going to simplify it a little bit first of all. So 1/9 is 4c. I'm thinking on, and I'm putting a 9 when I meant to put a 3. 1/3 is 4c divided by 9. So where that's come from there, look, the c's there. 1 times 4 is 4. The two minuses are cancelled out, so it's positive. And 3 times 3 is 9. So multiply both sides by 9. So 4c is 9 over 3. So 4c is 3. So c is 3/4. Then the next thing to do, we can put x is 0. Because we've done that one, look, x is 0 is next. So that's going to go, that's going to go. We'll get this one here. So 2 times 0 plus 1 equals a. 0 minus 1 is minus 1. Every time I'm substituting into here. A times minus 1 times 3 times 0 plus 1. And then that's b times 0 plus c times 0. That goes, that goes, that goes, that goes. So note of 1 is minus a. So therefore a is minus 1. Right. So we end up, so if we want, oh, it doesn't say, oh, I've missed off the integral sign there. Find the integral of that makes more sense. So I want the integral of 2x plus 1 over x minus 1, 3x plus 1 dx is therefore going to be the integral of a over x, which is minus 1 over x dx, plus the integral of b over x minus 1, which is 3/4. I'm going to put the 3/4 outside the integral sign. 3/4 1 over x minus 1 dx. And then c is also 3/4. So it's plus 3/4 times the integral 1 over 3x plus 1 dx. So this is minus ln x plus 3/4 ln x minus 1. Now this one, if you've got the integral of 1 over kx plus a constant dx, well that is actually 1 over k ln kx plus c. Okay, and that's because when you differentiate this, the ln means 1 over kx plus c, and you multiply by the derivative of the bracket, so you multiply by k, so it cancels it out there. Okay, so this is 3/4 times 1/3 ln 3x plus 1 plus constant of integration, which again I'll call log c because they're all logs, so we can put them all together. So that one cancels with that one, 3 there. So we can say this is ln, it's going to have a numerator and a denominator in here. The minus 1 is denominator. This one is x minus 1 to the 3/4. This one is 3x plus 1 to the 1/4, and the c can multiply in there. Okay. And that's a bit of method there. Let's just get that. Oops, come back. Didn't want that. Come back. There we are. Press the wrong button. I wish I knew which button I'd press then, because sometimes I do actually want to go to somewhere else. But I didn't then. I forget which one it is. I'll find it. Anyway, another one. Integral of... Oh, a little bit warm. A little bit warm. Integrate x cubed plus 5x squared plus 1 over x plus 1, x plus 3. Okay, so first of all, what we notice here is that the top, the numerator, it's got highest power 3, whereas the highest power of the denominator is 2. Okay, so what you've got to do is, well, there's a few ways you can do this. Let me just have a little think about which way's the best. Right, what we can do, let's do the partial fractions first of all. X cubed plus 5x squared plus 1 divided by x plus 1. I think this is the most efficient way. There's a couple of ways of doing it. X plus 1, x plus 3. Right, when you've got an x squared, an x cubed on the top, and we're dividing by x squared on the bottom, we're going to have x's plus constants plus a constant over x plus 1 plus another constant over x plus 3. So where this has come from, we've got an x cubed here and an x squared there. So when you've got cubes divided by squareds, you will get x's. So you've got to go down from x's. That's x to the 1. This is going to be x to the 0. And then we have our normal, whatever normal is in partial fractions, our normal partial fractions, c over x plus 1 plus d over x plus 3. And then we do, as before, multiply both sides by x plus 1 times x plus 3. So we end up with x cubed plus 5x squared plus 1. So it's going to be ax plus b times x plus 1. Now there's no cancelling with that first one. Okay, because there isn't any denominator. The next one, we get the x plus 1 cancels, so we're left with x plus 3. And the following one, the x plus 3 cancels, so we're left with x plus 1. Okay, let's start. If we put x is minus 1, the reason I've chosen minus 1 is because then that will make all that 0, so all that will go, and that one will go, so we'll be able to work out what c is. So we've got minus 1 cubed plus 5 times minus 1 squared plus 1. It's 0 for that first one, plus c times minus 1 plus 3 plus 0 for the next one. So it's minus 1, I'm on the left hand side, minus 1 plus 5 is 4, plus another one is 5, minus 1, yep, that's 5 on that side. Do that on your calculators. C times 2. So therefore C is 5 over 2, which we'll call 2.5. Okay. Next one, I'm going to pick x as minus 3. And that's going to make this 0 and this 0. So we'll end up with d. We'll be able to work out what d is. Minus 3 cubed, 5 times minus 3 squared, plus 1. 0, because it's got the x plus 3 in, plus 0, plus d times minus 3 plus 1. So left hand side is minus 27 plus 45, which is 18, plus 1 is 19. Oh, that number seems a bit weird. We'll just check that one. Minus 27 plus 45, which is 18, plus 1 is 19, yep, well, that's what I did in my head and on paper. 19 is 2d, So therefore D is 9.5. 19/2. We've still got to work out the A and the B. Now, what we can do, if we say the coefficients of x cubed, so that means we've got to look at all the x cubes. This one will always work. On the left, we've just got 1 x cubed. On the right, there's no x cubed there because the highest is x. There's no x cubed there because the highest is x. We can get an x cubed from here, from our ax times our x times our x. So we have x cubed on the left is ax cubed on the right. And we forget all about the squareds and the x's and the constants. So therefore A is 1. So we're getting there. Just B to find. And another thing, another good one, let's put x is 0 in and see what happens with that, because that quite often helps us. So on the left we've got 0 plus 0 plus 1. And then on the right we've got B in the first bracket, that second bracket times 1, and the third bracket times 3. That's 3B. And then that's C times 3. C times, and C is 2.5. 2.5 times C. Plus D, which was 9.5 times 1. Okay, so I've just put x is 0 in there, and I didn't write it down if it was 0, just spoke about it. So hopefully you can understand where that comes from. Oops, that should be blue there. Oh, there we go. Right, so let's see what we've got now. 1 on this side is 3B. 2.5 times C. What on earth is that about? 2.5 is C. It's 2.5 times... so I'm in this bracket here with x is 0, is 2.5 times 3 plus 7.5 plus 9.5. So therefore 1 is 3b plus 17, really? Okay, so 3b is minus 16, so b is minus 16 over 3. Okay, interesting numbers coming into this. I wouldn't put this in an exam because I want people to pass, not just get stuck bogged down with algebra. But it's in the textbook, so it's in the A-level course, so it's something you should know, really. So let's go back. It's our integral, original integral dx. I won't write it all out again. It's this one here. Let's do this in a nice colour. So this integral here, I've written that there. I didn't bother writing the fraction part because I'm not going to need it. So it's the integral of ax, which is 1, plus b, the integral of b, which is minus 16 over thirds dx, plus the integral of c, I'll put the c outside the integral sign like I did before, 1 over x plus 1 dx, plus d, 9.5 times the integral of 1 over x plus 3 dx. So this is x squared over 2 minus 16 over 3x plus 2.5 ln x plus 1 plus 9.5 ln x plus 3. I'll just put a normal plus c there because, keep that green's quite nice. I'll keep the normal plus c there because there's a mixture of logs and algebra going on anyway. Okay, and that was Thursday's lesson then.